Can you see this again? I have got the
No, I've taken the control
error.
from you.
Okay.
You can just replicate the error, then we'll have a look. Not a problem. Are you able to replicate it?
Yeah. Give me. Can you just show me? Give me 1 minute, and I can show you the error one more time.
Yeah, take your time.
Now.
Take your time.
Okay. So, can you give me the controller access?
Sorry?
Have you given me the controller access? I just wanted to. So basically, now the path thing has been fixed. Okay. And show my screen. So. It says failed to execute goal project map reduce could not resolve dependency on project is the following artifacts could not be found. All that Pentaho add designer algorithm jar 5.1 jhide.
पेंटा हो क्यों चाहिए यार? पेंटा हो चाहिए नहीं। फॉर्म कौन सी है? वही है जो मेरी वाली है।
एक मिनट यही तो आपकी फॉर्म है।
एक मिनट, कॉल ही नहीं आ रहा, दिख ही नहीं मतलब मुझे। लेट इट कम अप।
सॉरी अच्छा मेरा जेडीके ना 1.8 है, आपने जेडीके यहाँ पे डाला हुआ है 1.6।
हाँ, जेडीके 1.6 डाला हुआ है।
तो इसको मैं 1.8 करूँ क्या?
नहीं, बट तो तुम्हारे पास जावा का एरर आ नहीं रहा, तुम्हारे पास तो फॉर्म का एरर आ रहा है, वो तो बाद में आएगा। पेंटा को कहाँ से रेफर कर रहा है? एक काम करो, .m2 में जाके जितना भी कुछ पड़ा हुआ ना सब डिलीट कर दो। .m2 पूरा डिलीट कर दो।
पूरा डिलीट कर दूं?
.m2
ठीक है। user routing to एक मिनट फॉर्म में देखता हूँ, ठीक है।
ओके। .m2 तुम्हारे उसमें पड़ा होगा, जस्ट गो टू cd tilde एंड वहां पे .m2 पड़ी होगी। यहाँ से नहीं यार, यहाँ पे नहीं दिखेगा, वहीं से टर्मिनल पे दिखेगा, यहाँ पे दिखेगा। दिख गया? अच्छा।
पूरा .m2 डिलीट कर दूं या .m2 के अंदर जाके डिलीट?
नहीं, .m2 डिलीट कर दो, बना देगा अपने आप मेवन।
ठीक मैं एक काम करता हूँ, मैं इसको डिलीट करता हूँ, तो तुम क्लास चलाओ, फिर देखते, ठीक है?
ठीक है,
तब तक इसको मैं डिलीट करता हूँ.
okay, sure.
Okay.
So, okay, so we looked at the Hadoop 1.x architecture, where there was something called job trigger and task trigger, if you people remember that. So, however, we are right now running 2.x on our systems also. So this is all what everyone is using. So let's look at the 2.x architecture, and then we'll look at what are the differences between the 1.x and 2.x. So as now you have understood what was 1.x architecture, it will be pretty easy for you to understand yarn architecture. So yarn, as the name says, yet another resource negotiator. Uh, Yet another resource negotiator. It's basically, so there are some changes between the last architecture, that is 1.x architecture, and the yarn architecture, and because there were some major issues with that architecture. The first major issue was the job tracker. If the job tracker fails, everything what is running in the cluster is just lost away with the job tracker. Although there were ways to make them persistable on the disk before it fails and all those kind of things, but still that was single point of failure in the system, because job tracker was handling each and everything, what was each and every job which was running in the cluster. Secondly, so yeah, I hope you remember this architecture which we discussed. There was something called job tracker. There was task tracker which are running on individual nodes. They was pooling the tasks, right? So secondly, with the help of this architecture, 1.x architecture, there was a limit to the number of max node which we could have added to the cluster was approximately 4,000, and the maximum concurrent tasks were max to max 40,000 with that architecture, because there was the dependency was on a single task, single process, which was handling all your jobs. Then, as I already told you, job tracker was a single point of failure, and restart of that thing was pretty tricky. If you have to restart that process or that node, that was pretty tricky or complex task, because that was handling each and everything in the cluster, each and every job in the cluster basically. So they came up with a newer architecture that is almost similar, but there are a few significant changes in the architecture. So rather than your job tracker, there are two new things. One is called your resource manager, and one is called a node manager. And rather than your task tracker, everything runs in a container, and for each application there is something called application master. So what is happening over here is, so all the resources across the cluster are basically monitored by a person called resource manager. So if anyone wants resources, they contact resource manager that tells where are the resources available, on which node resources are available, and that is the person who basically manages all the resources across the cluster. So that thing previously job tracker was doing, but now that is being done by the resource manager. And resource manager is not doing anything other than the resource management. It do not manage your job in the cluster. Any new job is pooled in, so everything in this world runs in a container only. So in a container, there's something called application master which is pooled up. That application master then manages the whole history of a single job, and all the resources which are required for a job and other things which are required for one single job is managed by application master. That application master runs itself in a container only. So what happens up is, this application master contact with the resource manager tells where are the resources available. Based on that, that application master creates container inside which mappers or reducers runs up. So if this node dies and only one application master is running on this node, only the job which was being ran by that application master get killed. Other than that, everything else is running perfectly fine in the cluster. So there is no single point of failure in the cluster. So in detail, if you look at what is basically your job tracker and task tracker, how where they've gone. So there's something called resource manager, as I told you. So what job tracker was doing is being basically divided into two things. One is the resource manager and one is the application master. Resource manager does nothing greater than managing the resources in the cluster, which job tracker was previously doing. So that half task is given to resource manager and another half task was gone to application master. So rather than single job tracker managing all your applications across the cluster, each application is now monitored by a person called application master. So it's a new process which is pulled up for each and every job which is assigned in the cluster, and that each and every job has each and individual, basically individual applicant master, and that applicant master manages the whole life cycle of that particular job. So even if that application master goes down, we just miss or fail, or basically there's only miss of one application and everything else in the cluster is running perfectly fine. So there is no single point of failure in the cluster. The task manager, which is managing the task on individual nodes, which was basically interacting with the job tracker in the previous one.s architecture, is now being replaced by node manager. So this more node manager manages just this node as the task manager previously was doing. As you can see, there's only one process which runs on a node and that monitors the CPU, memory, and network other things on the node. This is what happens in the cluster. Now in 2.x architecture, what happens is I submit the job and I get a new this resource manager. So basically what happens is I as a client starts runs the job, get a new application ID. After I get a new application ID, I copy my resources, that is the code jar file, into the SDFS. Then I give a submit command to resource manager. Resource manager starts basically tells one of the node manager to start one application master. That application master gets the or basically calculates the input splits in the cluster, and based on that it calculates number of mappers which are required. Then it negotiate with the basically contact the resource manager, get the resources information, then correspondingly negotiate with those node managers where it has to start new containers, and on those containers your mappers and reducer runs up. So does that make sense to you, or should I repeat in detail again?
I just have a small question on 7 and 8. So, once node manager goes back to the resource manager, it comes back and say that, okay, I have a task to execute. So it will it will instruct. Basically, it will app master is already running, or it has to start. So can you explain after step 6 again?
Okay, so
Stage.
prior to step 6 is all similar to one.s architecture. We get a new
Okay.
application ID and we submit the job. Before submitting the job, we copy our jar files or basically the configuration to the SDFS, and then resource manager based on the availability. So resource manager knows where the resources are available. So it contacts one of the node manager where the resources are available and tells it to start a new application master which will manage the whole life cycle of that particular job. That application master gets the information about the input splits from SDFS for the job which it has to run up. Now, as it has got the information about input splits, it knows how many mappers are required, and based on the data size and other thing, it also calculates approximately number of reducers which are required. So based on that, it again contacts with a resource manager that I need so and so resources in the cluster. Please let me know on which node I can get the resources. Resource manager tells this guy, yeah, go to these and these nodes where on these nodes you can get the resources. So it's contact with those node managers and ask them to create or spool container for itself. And inside those containers, it runs its corresponding mappers or reduced tasks. Those mappers or reduced tasks get the data from SDFS and run your code or basically logic on the data. And similarly, they keep on contact with the application master and sends the heartbeat signal with what is the status of those things. So that all those things happens from these containers to the application master.
Okay. You said it really fast for a
Oh,
beginner.
okay. So
Okay.
I'll again repeat.
So, I'll just absorb it. I'm just trying to understand. Five node manager. So can I say it back to you so that that will
No.
be, and you can correct.
Okay,
Uh,
sure.
so your client code will submit a job to the resource manager and say that, okay, I need a new task to be done. So, and then at the same time, basically the jar file, so suppose the map reduce jar file, which we copied in HDFS is copied. Now, and then again, on that job ID, new application ID, I submit that and say that, okay, this is the job ID which I want to run. So the resource manager will go to one other node manager wherever this data is available, and it will say that, okay, start the uh, application master. So when the create container happens, in your previous slide, create container and the application master were two different
So
blocks.
so everything in this world runs in a container only, like EJP में containers होते हैं, similarly ये containers हैं जिसके अंदर आपके processes run होंगे. So these are the containers, JVM instances inside which your process runs up. So application master itself is the process which runs inside a container. Node manager and everything runs in a container only. So these are
So is
processes.
there two different containers for task and application master?
For task means
Those JVM, please go back to the previous slide.
this one.
नहीं, इसके पहले जो slide दिखाया था ना हमने.
This one.
It is not
विराज एक
refreshing.
बार आप प्लीज रिपीट कर दो थोड़ा सा.
Sure.
हाँ,
ऊपर
वो थोड़ा
Sure.
slowly repeat कर दो तो
और मेरी थोड़ा एक्सप्लेन कर दो.
Sure.
ज़्यादा क्लियर होगा.
Sure. So I am sitting on one of the nodes. मैं किसी एक नोड पे बैठा हुआ हूँ. I have to run a job. So you remember the previous one, job tracker, task tracker, वो याद है ना पूरा या वो भूल गए हो?
नहीं, वो याद है.
याद है.
याद है. ओके. सो मेरे को जॉब रन करने के लिए मेरे को जो वही जॉब ट्रैकर को कांटेक्ट करना पड़ता था, उसको मैं कांटेक्ट करता था, वो मुझे जॉब आईडी देता था. जॉब आईडी देने के बाद वो नंबर ऑफ इनपुट स्प्लिट्स कैलकुलेट करता था और बेस्ड ऑन दैट मैपर एंड रिड्यूसर चलते थे और फिर वो टास्क ट्रैकर्स उससे कोऑर्डिनेट करते रहते थे. वो नए टास्क से स्पूल करता था मैपर के लिए, रिड्यूसर के लिए. वो सब कुछ याद है ना? एवरीथिंग राइट?
Yes, yes.
सेम थिंग यहाँ पे हो रही है, बस थोड़ा सा फर्क है. रादर देन योर जॉब ट्रैकर विच वाज मेंटेनिंग एवरीथिंग इन क्लस्टर, देयर समथिंग कॉल्ड रिसोर्स मैनेजर एंड नोड मैनेजर आ गए यहाँ पे. और आपके जो जॉब ट्रैकर है वो उसका काम एप्लीकेशन मास्टर कर रहा है और रिसोर्स मैनेजमेंट का काम रिसोर्स मैनेजर कर रहा है. बस इतना सा फर्क है. सो आई द पर्सन सबमिट द जॉब, द जॉब गेट सबमिटेड एंड रिसोर्स मैनेजर गिव मी अ न्यू एप्लीकेशन आईडी. एंड मैं अपने जार जॉब की जो बेसिकली फाइल्स हैं, जो भी जार फाइल है, मैं उसको एलजीएफएस में रख देता हूँ जहाँ से नोड मैनेजर पढ़ के एप्लीकेशन मास्टर ट्रिगर करेगा और एप्लीकेशन मास्टर उसे कर के मैपर और रिड्यूसर ट्रिगर करेगा. बेसिकली प्रैक्टिकली देखा जाए तो रिसोर्स मैनेजर आपको रिसोर्स मैनेजर स्टार्ट्स योर जॉब. जो जॉब का फर्स्ट थिंग विच इज डन, दैट इज डन बाय रिसोर्स मैनेजर. सो रिसोर्स मैनेजर को पता है कहाँ पे मेरे क्लस्टर में रिसोर्सेज है, वेयर आर द रिसोर्सेज अवेलेबल इन माय क्लस्टर. सो ऑन द स्टेप 5 resource manager coordinates with one of the node manager and tell that node manager, please start a new application master which will be coordinating or which will be doing this job. Node manager spools a new container, a new JVM instance, and inside that JVM instance your application master runs up. Now that application master has to create mappers and reducers for our data to process. So in step number 7, that looks into your SDFS, looks at the data size. Based on that, it calculates the number of splits and the number of reducers. So it knows the number of resources or amount of resources which it requires for whole data to get processed. Based on that calculation, in the step 8, it contacts resource manager that I require so and so resources to process this data. Now resource manager is the only guy in the cluster who knows about the resources in the cluster, कि कौन से नोड पे कितने रिसोर्सेज खाली है, कौन सी नोड के पास कितना काम है, कौन सी नोड के पास कितनी रैम फ्री है, all those kind of things. So resource manager tells this application master in the step 8 that you can go to so and so node managers. They have so and so memory free or so and so RAM free. They have so and so capacity free. They can start your containers, basically your mappers and reducers. So based on that information which it has received in step number 8, it goes to node managers in step number 9 and asks them to start new containers inside which create the corresponding mapper or reducers. That node manager will create a container for you, and inside that container your mapper runs or reducer runs. Those mappers will get the data from SDFS, that is the corresponding block which is lying on that particular node, and will process that data. And in this whole life cycle, they keep on sending the heartbeat signals to the application master, so that application master knows those containers are running perfectly fine. And if they fail up or they die up, application master will re-trigger a container on some other node. So the same thing happens over here also. Now, does that make sense?
Yes.
Any questions still? So you can read these two slides. This will give you again good information. Just try to read this. I will not read it. You can try to read it. And still, if you have confusion, do ask me. Oh, sorry, I'm pointing to the wrong slide. So sorry. I'm pretty sorry. So this is a detail one. I pointed to the wrong slide. Sorry. And then got it.
Yes.
Yeah. So it's almost similar to that thing only. Only the difference is that task manager, sorry, job tracker is basically job tracker was doing two things over there. One, it was managing all the jobs. That all the jobs management is being divided into individual job managers. Those are called application masters. And the resource which job tracker was managing is that responsibility is given to a guy called resource manager. And there was something called task trackers which were running on the nodes. So those task trackers are basically now is pulled with the help of node managers in the containers, which basically are the individual mappers or reducers for you.
So one question which I had was, when a new go back to that architecture slide one more time, block diagram. Yeah, in this one, so when a new mapper or reducer needs to be initiated, it doesn't go back all the way to the resource manager. It will just go to the MR app master and just initiate another mapper or reducer.
Who will go back? Sorry.
So suppose the question which I am asking is, when we have to when a new map task needs to be initiated.
Map task तो ये initiate करेगा ना applicant master. Applicant master will initiate a new
हाँ,
map task. So now it has got the
अगर उसको
information from resource manager कि कौन-कौन सी nodes खाली हैं, and based on that it will coordinate with the node managers to start your mapper or reducer.
right. So the question which I had was that if a new map task needs to be initiated, it will not go all the way back to the resource manager, or will it? Or it will just contact the app master, and then app master will say that, okay, go to resource manager, and then resource manager will say that, okay, now go to this node.
Who will create a mapper? Sorry, the mapper, any new mapper will be created or coordinated via application master only.
Okay. This is fine. This architecture is fine. Suppose a new mapper needs to be initiated because
So
of the
that
new
new,
block of data.
sure. So that new mapper would be created by the application master only. Application master को नया mapper create करना है. So in that case, it will just coordinate with the resource manager. That वो बताएगा उसको resources कहाँ हैं. वो उस node manager से contact करेगा, नया mapper create कर देगा.
Okay, that is what I wanted to know. That will it ever? It'll have to go to resource manager always to get a new node.
हाँ, resource उसको तो पता
And
ही नहीं है.
then
Application master को तो पता ही नहीं कहाँ resources खाली हैं, कौन सी node पे चलाना है, वो तो उसको पता ही नहीं है ना.
तो उसके पास सिर्फ वो ये पूछने के लिए जाएगा कि भाई मुझे कौन से नोड पे चलाना है, बाकी जो उसका चलाने का प्रोसेस है वो सब एप्लीकेशन मास्टर करेगा. सो फॉर ईच जॉब आईडी देयर वुड बी ओनली वन app master.
For each job ID, there will be only one application master. Yes.
And that job ID will have multiple mapper or reducer. Good.
That job ID would have. देखो मैं दिखाता हूँ तो मैं उस दिन एक कोई मेरे क्लस्टर में जॉब्स चल रहे हैं, कभी चल ही रहे होंगे. Yes, that job ID will have, yes.
Okay.
Go to meeting. Let me start go to meeting. It's 173 only in ID, yes. चल रहे हैं, बहुत सारे चल रहे हैं इंडीड. So, am I there in the audience view? Yeah, so audience away attendees. Raj. Show my screen. So you can see my screen. So you can see my screen, right? So here you can see there are a lot of applications which are running up. So practically these are all individual jobs which are running up.
I can just see a black screen. I can't see the data on it. I could just see your.
I can see the.
No, your data connection थोड़ा slow है तुम्हारा.
Okay. ठीक है.
So
मैं वेट करता हूँ.
because I can see on my other laptop जिससे मैं present कर रहा हूँ. So it's visible, I'm sure.
I could still see the design Pathshala.
Net की speed थोड़ी slow है. I think yours.
Okay. Anyways, मुझे concept समझ में आ गया,
So
but
so this there's an application ID which is associated to each job. Application will then have your कोई running नहीं है क्या अभी? So this is the application master which I was talking about, and that application master will have all the container inside it. So you can see there are two mappers which are running inside it, and so you can see two mappers inside running it, and reducer is yet to run up. And so if you look at the containers, map task application, uh, jobs. So these are the two mappers already ran up. Reduce task is still to run up, and so uh, कंटेनर्स वाली स्क्रीन किधर जाती है? बंद रनिंग है तो कहाँ गया पीएम मास्टर यार? I can see all the containers. I just wanted to show the containers. वो कहाँ दिखेंगे वो समझ नहीं आ रहा. These are containers which are running up. These are done. So each container is running your individual task. खत्म हो गया वाला. So this is a container which is running your mapper, and this is reading your this data. So basically, for each of your individual job, there is applicant master which runs up. Okay, so in sometimes you might have seen something called abort task being enabled kind of thing, or abort task also too if you run your jobs on your individual जो setup करा उस पे अगर चलाया हो तो देखा हो तो. So basically what happens up in 1.x architecture is for each and every job there has to be a new task tracker which need to be created up, and job tracker की सारी booking activity सब कुछ करना पड़ता था. But what can be done in this architecture is if you have enabled the abort task, and so based on the job configuration, your yarn can think of whether it has to do all that overhead and bookkeeping activities to create your new container, coordinate with the node managers to create your new mappers kind of thing and reducers kind of thing. It can run your whole job in the application master itself. So if the data size is very small, it can run your whole job inside your application master only, and that reduces all that overhead of creating the new mappers and new reducers for very small jobs. So that is basically called double task. So if you have enabled double task by default, that is false. If you make it true, you can see your small jobs can run inside your application master itself, and new containers are not spooled for your small jobs. And how we can configure small jobs? Everything is configurable. So inside the parameters, you can just set the corresponding double task enabled and the max mappers or maps reducers or maps number of bytes based on which it will think of whether this task need to be made abort or not. And less than 10 mappers, it can basically spool in a single container. So this is what I was talking about. It keeps on sending the updated status to your application master so that it knows what is the status of your application right now. And it pulls for the status, and this is how that is visible to you on your UI or on your console.
So if Abertas doesn't run on a different node?
No, Abar task सब कुछ यहाँ पे सब कुछ application master में चला देगा अगर if you have configured Abar and sees कि तुम्हारा data size small है based on the configuration, how much small that you can configure based on the bytes or based on the max mappers and all those things. So it will run everything on your application master. अगर data एक से ज़्यादा blocks में होगा तो वहाँ से data copy होकर यहाँ पे आ जाएगा in that particular scenario.
So, but this looks to be the architecture which you're showing. It looks to be the yarn architecture, right? Because this is
this is yarn architecture only.
okay. But what you're saying, okay.
But no, this is how so after submission of job the update status is this is slide. This is not the our task slide. Our task
Okay,
slide
got it.
So here I was showing that how your status is updated to the client.
So the difference is basically instead of in 1.x, instead of going through the job tracker, now the status can go directly to the from the application master to the client.
हाँ तो जहाँ पे आप जॉब ट्रैकर का है ही नहीं ना यहाँ पे there is nothing called job tracker, so that job tracker work is done by the applicant master only.
Right.
So these are few admin related things. The differences between 2.x and 1.x architecture. So as I already told you, there is something called secondary node in 1.x. However, there is something called checkpoint node, which you have seen up. Processing everything happens with the help of yarn, and there it was mapper and reducers, which was handled by job tracker and task tracker. Then these are the file paths which are there in your cluster. So there are some changes in those paths. There's one more extra XML file, configuration file, that is yarnside.xml. I'll show you on the Ambari UI. Then these are the few changes on the ports, so different ports. Then these R files and all those things. So these are some configuration related things which are written over here. You can just go through them. There's nothing to explain in these things. These all are configuration admin related things. You can just go through them. There's nothing to explain in these slides. So I can show you the Ambari UI that will make little sense to you people. So what I can do is, okay. So what I can show is, so basically you can just type 127.0.0.1:8000 and that will open a UI called, oh not sorry, 8000. It runs on 8080 I think.
My screen has actually like I'm seeing a lot of black screen and just only one section of this thing is coming up. So is it something? And it started when you were sharing the map reduce task. So is this a setting at your end or my end?
No, everything is running. Pravjit, are you able to see it?
Yes.
You're saying in the full screen?
You're showing
Ambari UI, yes.
desktop.
Yes.
No, I am able to see it, but it is only squeezed to a small screen.
No. For me, it's full screen.
Okay. So I'll have to go back and come out and go back to the meeting. Okay.
Sure. So basically I've pinged to the Ambari UI. So this is basically used for cluster management. To log in, you have to just type password as admin only, and that will open the Ambari UI for you. So this is what I was showing you also previously. So that is from here you can manage the whole cluster. Should show you the cluster state, cluster पे कहाँ पे क्या चल रहा है, how much is the memory used, and all those things, and all the configuration which I was talking about can be done directly from here. I'll just wait for that Shikhar also. Okay, you back, right?
Yes, Miraj.
Okay, so on the Ambari UI, you can just type admin and user and admin as a password. That will open you the Ambari UI. From the dashboard, you can see the different stats about the cluster, how much is the unused, never used, CPU uses across the different nodes and all those things. And the configurations are talking about you are stored in the configuration files, but everything is managed from directly. You can manage directly from the Ambari UI. Otherwise, you have to go to each and every node. So if you have 100 nodes cluster, you might have to go to each and every 100 nodes to change these configuration files, which is practically impossible. So all the configuration across the cluster can be managed directly from the Ambari UI. If we look at the SDFS configuration, you have to just click on SDFS, click on the config tab, and that will show the configuration about SDFS. So that will contain so that will basically contain two major that is stored is basically two major XML files, codesite.xml and sdfset.xml. These are two configuration files for SDFS related configuration. So you can see all the configuration parameters which are related to SDFS and name node. SDFS and name node you can see the data nodes, replication vector, block sizes, logs, where to put up logs for SDFS, data node related things, data node की heartbeat related things, all those things. DFS is all distributed file system data node. Then coresite.xml will have configurations related to your Hadoop users and all those things. And SDFS site will have again the SDFS related things, that is distributed file system related things. And you can add the property from here. So there are a lot of properties which are there. You can just look at the core. So there are a lot of properties. You can look at the default properties which are by default configured. You can override them. So these are the properties in your core default core site.xml. Similarly, your SFSR.xml have another related. So all the Hadoop security authorizations. So I'll just quickly go through these things because these are all related to Hadoop administration, which we are anyhow not covering up. But I just wanted to tell you so that if you face any issues while you're running your cluster, you at least have the knowledge where to look at. So in the yarn, you will see the yarn related things. So here you can see the yarn related things. It has all your yarn related things, and yarn sort.xml is a yarn configuration file which contains all your yarn related configurations. Node manager, application master, वो सब यहीं दिखेंगे आपको. And if you have to go to those links, you can just click on the over here and this will open your resource manager UI. So this tells you the resources in the cluster and all the resources within the cluster, all those things. The currently running applications. So right now this is a local machine. Then map reduce will have individual map reduce related configurations. So mapper को कितनी memory देनी है, by default Java की memory कितनी देनी है, reducer को by default Java की memory कितनी देनी है, all those things. And execution framework here I've defined as yarn. Then you can look at all the nodes in the cluster directly from here, from the host. यहाँ पे अभी एक ही है क्योंकि there's a single node teaching, and all the processes which are running on that on a particular node, you can look at all those things. So Tej is a different execution engine said to be 100 times faster than MapReduce, which is available with the latest version of Hortonworks. And Storm is for real-time processing. Falcon is a framework on top of Uzi. Kangli and Nangios are basically for monitoring the cluster. Zookeeper is coordinator. These things you will slowly and slowly digest all these things. But I just wanted to quickly show you this thing so that you are aware of कि cluster कहाँ से manage करा जा सकता है, cluster की configuration कहाँ से change करी जा सकती है, and all those things. So just waste your 15-20 minutes and then you will be able to get little feel about what are different things running in your cluster. You can go to your यहाँ पे नाम क्या है, so metrics is about the cluster whole metrics बता देगा ये आपकी आज तक की जब से cluster run हो रहा है, year whole year की metrics है, कितना CPU हो रहा है, job के related, nodes से related, graphs, all those things you can create it over here. So पूरा cluster basically you can manage up and look up, monitor your cluster directly from here, from this Amari UI. You people are with me?
Yes.
Yeah.
Okay. Okay. So you can just play around with this UI. This is all related to admin work, but you should be aware of because you are working as a developer. So many time you face problems, and then this is the whole source of truth. What is your cluster all about? Okay. So now we'll start Hive. So let's take a break and then start a new thing, Hive. And before that, if you have any questions, most welcome. Okay, so I'll assume no. So let's take a quick break, 10 minutes.
Yes.
Okay. Okay, then let's meet and then we'll look at the Hive. So Hive, you should look at, sincerely and thoroughly because if you are really working on Hadoop, 90% of your jobs or 90% of your development task or 90% of your work would be done in Hive only. You will be really writing a map reduced job or you will be really writing a big task. You will be rarely looking at yarn क्या होता है और job tracker क्या होता है, task tracker क्या होता है और mapper क्या होता है, reducer क्या होता है. You will really care about those things. All you'll be doing is writing Hive query और data process करोगे, and you will be looking at that process data. So, but now you understand the basic of the cluster कि अंदर कैसे चल रहा है, क्या चल रहा है. So it will be pretty easy to understand for you to understand Hive, and it will be pretty easy for you to think of कि कौन सा file system मुझे use करना है, कौन सी configuration मुझे use करनी है, कौन सी zip file मुझे, कौन सी compression मुझे use करना है, and basically cluster कितना बड़ा होना चाहिए, and all those things. Now you could be easily guess up and what is happening at the backend in the Hive, how you can basically increase the basically reduce the processing time for your queries and all those things. You'll be now able to think in those directions. So trying to understand Hive बहुत easy है. All of both of you work on SQL. So I hope you both of you are aware what is SQL things. So that will not be a difficult task for you. So, but just try to. So, but what I all mean to say is just try to burn your hand with the Hive, because 90% of the time you will be working on Hive only. Okay, then let's meet after 10 minutes. It's 21:43 or 45, you can say. So let's meet at 55.
All right.
I am back.
Is that Miraj or Pravjit?
I'm Raj.
I'm back too, so we'll wait for Pravjit.
Sure.
I'm back.
Back?
Yes.
Okay. Okay. So, sure. So let's then look at the. So I've shared you the latest slides which we have covered today. I'm just opening up the mm, Hive. Uh, okay. Okay. Hmm. Okay. So Hive is a kind of query interface on top of your SDFS. So rather than writing a complex MapReduce job to process your data, you can pretty easily interact with your data with the help of simple SQL queries. So Hive helps you to basically interact with your data in the terms of those simple SQL queries. Okay. So it was developed at Facebook, and most of the Facebook jobs are written onto Hive only. So it gives you a kind of relational database on top of your SDFS file system. It supports your major things, what other SQL like languages suppose, like partitioning, clustering, complex data types, and optimization on your queries. So what was the problem with the any other warehousing systems or the MapReduce part was? So for simple things, you might have to write your Java code, and there are a lot of complex things which you have to handle in the Java code, and the learning curve for MapReduce is pretty lengthy. So they came up with a solution called Hive, where you can just write queries like select star from table so and so, and that will write at the backend transparently MapReduce code for you. So that helps you to manage your unstructured data, and as if it was basically structured. So all your data into SDFS is basically unstructured data. So you manage your unstructured data as if that was basically structured with the help of Hive. How that is done is, so okay, so before how that is done, let's look at one pretty simple thing. So here what I'm doing up is, so I've written single line code. So this is a single line code, indeed two line code basically. So this two-line code is equivalent to your word count program, which we did in MapReduce. That was 65, 70 line word count program, which you have written up, mapper class, reducer class, and the job configuration things which is done up. And then we run Maven clean install, और फिर उसकी जार बनाई, वहाँ पे लेके गया, जार को compile करा, वो सारा task करा, जार चलाई, and then we were able to do the map word count. But all that thing can be done in just these two lines of code. We'll be able to get the count of the words. So don't worry about a complexity lateral view and other things. A row format delimiter. We'll talk about all those things in detail in our next few slides. But just what I wanted to show you on this slide is how easy our life becomes with the help of these um, tools like Hive and Pick on top of your MapReduce word. So Hive runs on top of your MapReduce. It converts your query into map and reduce code, and that runs on your SDFS. So that data processing happens with the help of MapReduce only. Okay, so let me open the terminal. Okay, यहाँ पढ़ा नहीं है, ठीक है, कोई बात नहीं. We'll copy this thing only rather than writing it. So sorry. Oh yeah, I'm working on Mac. Sorry, I forgot. I am working on Mac.
विंडोज है.
So मैं वो कमांड से कर रहा था, कॉपी नहीं हो रहा था. Mac और Windows में कंफ्यूजन आता बार बार. Okay, so what I did is I just wrote two lines. फिर से वो कॉपी नहीं होना. Command C नहीं, Control C. So what I did is I created a table on top of my file with the help of create table command. So that file now is referred by this table called doc, and I'm doing a select from that doc and printing the word count, all the words in my file word count. So first we'll look at इस डायरेक्टरी में कुछ डेटा पड़ा हुआ है क्या, और कुछ फाइल पड़ी हुई है क्या जिसके ऊपर हम वर्ड काउंट चलाएंगे, and rest all will run this. Okay, so Hadoop fs minus ls. अगर नहीं पड़ा तो we'll just put some dummy file over here. There's something over here. So we'll try to print the words in this file. There's something in this file. We'll try to do a word count on this file. So there are three ways to run any Hive command. So यहाँ पे कुछ तो अजीब सा output पड़ा है कुछ. So there are three ways to run a Hive command. One is Hive -f and the file name. So we created a file called wordcount.sql. So -f is the file option to the Hive command. So I just typed Hive -f and gave the file which it has to run. It will run that file for you. There are other ways also to run a Hive command. I'll show you them in some time. So see, the mapper and reducer started. So we did not write a single MapReduce code. We have just written two lines. We created a table on top of that file, and we just ran a select query. And it has written the MapReduce code, everything at the backend for you, transparently to you. You don't have to worry about any of that complexity, and you will quickly get the word count. And this application ID on which we can track that application. So you can see application is running up, and these are logs based on the application. And अभी वो sign नहीं हुआ यहाँ पे. Applicant master is here. So it's running that query for us. We can look, there's the job ID. We can look at the individual mappers. We can look at the individual reducers and all those things. We can look at the logs of the applicant master over here. So see, I've got the word count. Cool. You don't have to do anything. कोई जार नहीं बनानी पड़े मुझे कुछ नहीं करना पड़ा. Everything is done up in just 2 lines of code. So that's why I was saying previously also to you, you will be really writing your MapReduce code, but you have to understand the concept. If you understand the concept, everything will become very easy in this word for you. So as any other thing, it supports your data types like integer, boolean.
Miraj,
Yeah.
Miraj, can you do me a favor? Can you just go again back to where you created the file and how did you run the command? I just want to see that step one more
Hive.
time.
So hive minus f, and any file which have your command, you can just give that file. Hive minus f.
Okay, and it will be done. So I saw that hue at okay. So you got hue at sandbox hive. So once to initiate, do you have to initiate any cell over it, or how does it? How did you get?
I think you have to do
This pointer.
SSH करना पड़ेगा ना. SSH to colon 2222 पोर्ट पे 127 पुट्टी वाला जो मैंने बताया था आपको मैक के अंदर SSH करना पड़ेगा. विंडोज में पुट्टी पुट्टी खोलनी पड़ेगी.
ठीक है. So you do SSH 127. Yeah, I'm just saying back to you. Yeah.
पुट्टी खोल के सॉरी मैंने खोल दी. Recent session. So we'll just do on this port number 2. We'll just open it. Username is you. Password is Hadoop. So over there, that now I'm connected to my hot and mouse box, and over here I'm just running the hive command.
Okay. नहीं ये पहले ये हाइव का जो रूट में दिखा रहा है ना कि सैंडबॉक्स एट हाइव
ये तो फोल्डर का नाम है यार.
ओके गॉट इट. ये तुम्हारा फोल्डर. ओके गॉट इट. मुझे लगा कि हाइव का कुछ सेल चलाना पड़ता है पहले.
नहीं, nothing. Everything is configured in that machine. That's why I told you I've given everything configured in that machine. So you don't have to worry about any of the administration related things.
Okay, now I'm good. Thanks.
Okay. So as any other language, it has all its primitive data types: integers, boolean, floating points, string, timestamp, all those things, and some of the complex data types like struct, map, key and value pair, and arrays. So you can create table on top of your directories. You can just define this directory. Any of the data inside the directory will become a part of the table. You can even create a table directly on the file also, but practically suggested to create a table directly on the directory, because you might have a number of files which you want to associate to a single table. So basically, this is how we create a table on our file or on our data in our SGFS. So here what I'm doing is, so I have a table with table name design Pathshala underscore employees. That table has first column called name of the employee, salary of the employee as float, subordinates, that is the another employee is reporting to him or his or her subordinates. So an employee can have n number of subordinates associated to him. So that subordinate is basically an array of string. Deductions is his tax calculations. So there can be n number of tax calculations which is associated to his salary, like uh, um, tax one, tax two kind of thing, and the corresponding rate of the tax. So we are storing that as a map. And last thing is his or her address, which we are storing as a struct. So inside the struct here, that will be the street, city, state, and zip, his complete address. So this is how you can create a table. I'll quickly show you the data also. And then we tell, so any comment on the table, if you would in future want to refer to that comment. So there's just a comment associated to the table, partitioned by, just ignore for next few minutes. These are the interesting part about the data. Row format delimited, fields terminated by /001 is control A. So fields inside this table are terminated by control A. Collection in this table are terminated by control B, that is /002. And this map keys are terminated by control C. And lines are terminated by control slash, and that is new line character stored as text file. So what exactly these things mean? So basically what we are doing in the data is, so this is our practical data. यहाँ पे अगर देखोगे, so this is our data. So you can see name, then this is a control A. So what I'm saying over is, मेरी fields are terminated by control A. So fields, that is my name, salary, subordinate, each of them are separated by control A. So यहाँ पे you can see zone control A, his salary control A, his salary float, then control A, then he has subordinates which are terminated by, so collection items are terminated by control B. So इसके जितने भी subordinates हैं, those are terminated by control B. So Mary Smith, control B, Todd Jones, these are his subordinate. Then control A, that is a new column, federal taxes. Map keys and values is terminated by control C. So the deductions, federal tax deduction is 0.2, state tax deduction is 0.5, insurance deduction is 0.1. Then his address, these are collection fields, again terminated by control B, and slash and character over here. So this is one record which is over here. So this is your one record. So you just define कि data किस तरह से delimited है. This could have been comma separated. This could have been in a JSON also. This could have been any of the separators. By default, the separators for maps, fields, and collections are control A, control B, and control C. If you don't define, these are default separators. That's the reason I'm showing you in the first slide how your data is by default stored up. And your lines or rows are separated by slash, and that is new line character. So this code data could have been in JSON also like this. You would have just used the JSON reader or JSON input format, and that would have read your data, and you have to just define the columns associated to your key, and the rest everything is done by the Hive. I'll show you all those things.
And for Jason, do we need to change that stored as text file? वहाँ पे change करना होता है.
हाँ वो भी मैं बताऊंगा. इनपुट फाइल फॉर्मेट आपको डिफाइन करना पड़ता है. इनपुट फाइल फॉर्मेट कौन सा यूज करना है? यू रिमेम्बर इनपुट फाइल फॉर्मेट याद है ना? मैपर में पढ़ा था हमने. मैं इनपुट फाइल फॉर्मेट जो डेटा रीड करता है.
Right.
तो हम यहाँ पे बस इनपुट फाइल फॉर्मेट डिफाइन कर देंगे, एंड दैट विल डू अवर वर्क. So rather than all this buzzard, we'll just use JSON Saturday, and that will do all over for you. So I'll show you all those examples. So practically data आपका SDFS में पड़ा होगा. You have to just define कि आपके data को किस तरह से read करना Hive को. Hive will never store any of your data. All your data will be lying in your SDFS. Hive will just store metadata about your data. That is how to read your data, how to process your data. Your data will always be in your SDFS only. If you drop a table or basically all your table related things, or what metadata about your data, that is only the thing which is stored into Hive. So similar to any of the database languages, you can create a database. So create database, database name will create a database for you. Create database if not exist, create show databases will show you all the databases. So all of you, both of you are aware of MySQL, na? MySQL पे काम करा होगा ना? Most of the commands are equivalent to MySQL or Oracle or Microsoft SQL kind of thing, but mm, exactly similar to MySQL. Most of the things, mostly similar to MySQL. So if I go over there, uh, so to go to the Hive console, this the Hive -f is the one way to run Hive command. Another way is you can go to the Hive console and can run the Hive commands over there. So how to go to the Hive console is you have to just type HIVE and press enter. That will take you to the Hive console. So this you can see now we are on the Hive console and now you can see Hive colon that is Hive console. So here if I say show SCS databases, it will show me the databases. So there are two databases. Default is the default database which is always there, and DP is a new database which I've created up, that is design personal database. And similarly, you can create database and define the location in the SDFS file system for that. Oh, sorry. So you can see this database pointing to this location into a SDFS. So if we look at this location, there are folders associated to each table. So I'll open another putty, Hadoop fs minus ls. So while creating a database, so there are a lot of folders inside this. So these are the tables, basically each folder is associated to a table. So while creating a database, you can also define the location where you want to keep this database. Otherwise, it will create a database with a default location. What is the default location? That everything is configurable in the hive.xml. And you can configure those things from the Ambari UI. So by default, the location of any of the databases in Hive is /apps/warehouse/hive. Inside that, all your data lies in SDFS. /app/hive/app/hive/warehouse. Otherwise, you can define it over here. You can give a comment to a database. Describe data, I just did it. That shows me the description about the database. Describe extended will give you a little bit extra information, but that will make sense when we do it on a table. I'll show you on a table. And if I set this thing on the console, this will start printing the database on which I am there. So these are there are a lot of configuration which you can do on Hive. So these are the different configuration parameters which are associated to Hive. You can change them. These are default values which are given to them. These all of those default values come from your hivesite.xml, which you can change it on the Ambari UI, or if you want to just change those things in this session, you can just change it with the help of set command. So here I'm changing one configuration, that is print CLI current DB. So if I set this thing, my current DB will be printed with the console. So यहाँ पे hive के साथ brackets के अंदर DP लिखा हुआ आ जाएगा if I'm using the current database as DP or default if I'm using current database default. And drop database is the drop.
Miraj,
Yeah.
okay. Miraj, can I ask you one question? Go to the other SSH window. What were you trying to look through that window? I didn't get it.
Which
So
window?
here you ran the Hive shell, and then you could describe the database and everything. But the other window which you opened, I didn't get what you were trying to. Which file system were you trying to get to?
This is Hadoop file system.
एक और
Hadoop file
हाँ
system में database describe करा था ना मैंने यहाँ पे, describe database याद हो तो इस describe database ने बताया था मेरे database की location क्या है. There is this location. So I was showing you this location. What is lying in this location into your SDFS. So we looked at this location into SDFS, and these are the directories inside this location. So these are, each directory is pointing to a table.
This URL on the web browser, I think it will just list the directory, right? All the files.
All the files, yeah, directories basically. So over here, Hue की UI कहाँ गई? So if I open the Hue UI
okay.
for you, file browser, अबे यार. So these are directories. Each of the directories basically are table. I'll show you these tables. So inside these tables, there are files which have the data, real data, which is associated to this table.
एक मिनट अच्छा मुझे लैग आ रहा था इसलिए समझ नहीं आता एक मिनट go back one more time please. So there was a out of sync between what you were telling and what was shown on the screen, so that's why I didn't
Actually Shikhar, yeah, when you share your desktop then also there's a lag. I think कुछ correction problem है. I think your connection is, you are using some 3G 4G what?
No, I have like I checked my connection. I've got speed of around 20 Mbps, and I'm on cable network.
I don't know. Prabhjit, you also see a lag?
No.
And I also, when I opened my other laptop,
mine is only 5 Mbps.
Mine is 16 Mbps, but still, matlab, I see a lag when you describe also.
Anyways, तो basically जो second shell script तुमने खोला उसमें shell this in this one you want to show all the described database all the databases which you listed. Each of them in this Hadoop file system is mapped to a folder.
यार सब कुछ SDFS में है, सब कुछ आपके फाइल सिस्टम में है. फाइल सिस्टम में क्या होगा, फोल्डर्स होंगे. तो आपका डेटाबेस एक फोल्डर पे पॉइंट कर रहा है, डेटाबेस के अंदर टेबल्स हैं, टेबल्स उन फोल्डर पे पॉइंट कर रही हैं, फोल्डर्स के अंदर फाइल्स हैं, वो रियली डेटा है टेबल्स का. So everything in the file system, we are moving back to the file system world. We started from the file system, moved on to relational databases like Oracle, MySQL, Microsoft SQL. Again, people are moving back to the file systems.
Okay. So one more thing is, you had a database. Take any one database which you show. Don't change the screen because otherwise it will again have that lag. So there was a database called OK or something, right? Where is the file for that?
Database की कोई फाइल नहीं है, फाइल तो टेबल से एसोसिएटेड होती है ना. We have just created a database. Database के अंदर टेबल्स बनाते हैं ना.
तो मतलब ये जो जितने भी मतलब सारे डेटाबेसेस के जो फाइल्स होंगे सब एक साथ लिस्टेड होंगे क्या?
नहीं, वही तो मैंने दिखाया है, वही तो मैंने लिस्ट करा. डेटाबेस की डायरेक्टरी लिस्ट करी, इसके अंदर सारे फोल्डर्स हैं, दिख रहे हैं. दीज आर ऑल फोल्डर्स. These are all folders. These are the folders. That is what I show you on the Hue also. These are all folders. These folders, each folder is associated to a table. And इन folders के अंदर files पड़ी हुई हैं जो कि tables का data है.
Okay. So don't move your screen. I'll just speak, okay? Because when you move the screen, then again we'll be out of sync. So right now, what I can see is on top of it there is a okay. Bring back that black screen. ये जो है ना dp.db, right? इसके ये जो dp.db था, इसके अंदर सुपर स्टोर सेल्स रिटर्न, राइट? ये क्या है? टेबल है, करेक्ट?
Folder basically that is a table all in the database, and the table has a folder inside this directory which is associated to the table.
एंड return.csv क्या है?
क्या?
Okay, so okay, don't move your screen. Okay, I'll just ask questions and then I'll understand. Okay, because when you move the screen, I am out of sync.
I'm not moving my screen from last 3 minutes. The screen is
Okay,
there only.
so right now what I can see is there is a hue at sandbox. The last command which you typed is that you listed the file which is under dp.db, right? And you got ABC cluster table team underscore country. These are the tables which you have under dp.db, correct? Right?
Yes.
Okay. What I want to know is all this table which is ABC or cluster table is stored as a file in Hadoop file system, correct?
Data जो भी होगा files के file ही होगा basically, practically at the end file में होगा data.
Okay. अब ये file का जो data है, it will be defined on the delimiter which you had presented, like control A, control B, control C, and that directory, correct?
Yes.
Okay. Now, अब मैं एक cat file करके देख सकता हूँ क्या? कोई भी एक file, ABC या जो भी file
Don't worry, अभी तो we've just looked at the first slide. I'll show you how to create a table. We will create a lot of tables. We'll do all those things. अभी तो I'm just showing you the database only. I'll show you all those files. अभी हम सब करेंगे. Just wait. We'll do that thing. अभी तो हमने tables देखी नहीं है. We'll look at the tables in detail. We'll look at the tables, partitions, serialization, hive. We'll look all those things slowly and slowly. Okay, so I've shown you a glimpse of how to create a table. Let's look at, we'll try to create some tables also on the files, and we'll look at the data. So you can also give the location where your file is lying up like this, and you can create a table on top of that directory. So let's try to create one table and let's see. So what we'll do is I'll just exit the Hive console, or let's keep on running this. So I'll tell you the difference. What is the difference between external table and internal table? But let's try to create a table. So what I'm doing is use database, use DP is I'm using the database called DP. Then I'm dropping the table stocks if that is already existing, and then creating a table called stocks. So what I'm saying over here is row format delimited field separated by comma. So that means my file is comma separated. So my fields in this file is comma separated. So if I open this folder for you, so you can see this is my real data, which is comma separated, and I created a table on the CSV separated file. So I have a lot of data. The first column is basically a stock name. The second column name is the start price of that stock on which it traded, the days lows, days highs, number of traded values, the trade date, and all those things related to a stock. So what I did is I gave a command called create table. If not exists, table name. The columns which are associated to the table. So first column is stock name or symbol of the stock as a varchar, price open as a float, price high, price low, price close, volume of that day, the date as date. I set the terminator as comma and location, and rest everything is done by Hive for me. So if I say select start from stocks, it will show me the data. I say where मेरे कॉलम के नाम क्या थे symbol is equals to SBI. So it will run a MapReduce job now for me. Previously it did not run a MapReduce job because I had to just do a file ka cat. So it did not run any MapReduce job for me, but now I am doing some where clause. So it will write a MapReduce code for me and will try to process the data and will figure out the data which is intended for me based on the query which I have given to the Hive console. At the backend, data is lying in the file system only in a comma separated way. So here what I did is I created this data table inside a database called DB, and so see inside the database called DB, and this is a location of the folder where my files are lying associated to this table. So ऐसा कोई मैंडेटरी नहीं है कि अगर टेबल डीपी में है तो वो फोल्डर भी डीपी में होना चाहिए. You can just give the location any other than DP also, and that will be a table associated to the folder database database DP, but the folder might be lying somewhere else also. But the default is your database, your table folder will be created inside your database folder. So
What
these
file have you used? The original file?
original file is this thing, the CSV, which I opened inside the stocks folder. There's a stocks folder. Inside this, there's a file called
Okay.
stocks.data, single file. I would have 100 files over here also, but अभी एक simple file एक ही पड़ी हुई है. I could have
ठीक है,
hundreds
तो
and thousands
उसको
of
ये
files.
बेसिकली CSV फाइल ही है. और हाँ, एक बार दिखाना जो वो क्रिएट टेबल वाली थी. ओके, तो क्रिएट टेबल, तो आपने सारे कॉलम डिफाइन कर दिए और उनको फ्लोट वगैरह सब दे दिया, इंट कर दिया, फिर बताया कि जो डिलीमीटर्स है वो कॉमा है, राइट, और
Yes.
लोकेशन दे दिया. अच्छा, इसमें अगर कोई डेटा टाइप मिसमैच हो गया, जैसे प्राइस अंडरस्कोर हाई को आपने फ्लोट कर दिया, अगर वो स्ट्रिंग हो गया बाय चांस, तो क्या करेगा? ये
वो
एक्सेप्शन
कर
थ्रो कर देगा?
नहीं, हाइव कोई एक्सेप्शन कभी नहीं थ्रो करता.
तो
Hive
फिर
is
मतलब
बता. Yeah, so Hive basically is a store metadata about your data. So Hive will never throw any exception on your data, and इतने बड़े data पे it's always a probability कि आपका data corrupted में all those things. So Hive will just try to convert that data to the corresponding type. अगर वो कर पाता तो ठीक है, अदरवाइज रीड करते हुए वो टेबल में डेटा थ्रो कर देगा. जब आप टेबल बनाओगे तब वो कोई डेटा कोई एरर थ्रो नहीं करेगा. सो इफ आई से क्रिएट एक्सटर्नल टेबल, लेट मी जस्ट ओपन क्या कहते हैं फाइल ब्राउजर, नोटपैड और टेक्स्टपैड खोल लेता हूँ. टेक्स्टपैड, ठीक है, कमांड भी बंद हो जा. यार विंडोज पे काम करने भूल गया मैं तो. रिप्लेस with nothing, replace all. Okay, so let's say I call it integer, ठीक है, एंड इसको नाम देते हैं स्टॉक्स 123. मैं सेम फोल्डर पे एक और टेबल बना रहा हूँ. डज नॉट मैटर। हाइव जैसा मेटाडेटा वो आपका मेटाडेटा रखेगा। जब मैं इस टेबल का नाम दूंगा हाइव को, हाइव उस फोल्डर पे जाएगा जो जिस भी फोल्डर पे टेबल पॉइंट कर रही है,
हेलो।
वहां से डेटा। यू कैन हियर मी?
यस, एक्चुअली जब मैंने क्वेश्चन पूछा था ना, उसके बाद से अभी तक ऑडियो चला गया था, अभी वापस आया।
Okay, so I'll repeat. So what I'm saying is, Hive will never throw any error for you. Hive just stores the metadata about your data, and metadata is nothing but your table definition or your database definition kind of thing. So when I give a column data type which is not matching your data, Hive will not throw any exception for you. Hive will just store that metadata inside it, and rest all processing or error throwing kind of thing will happen when I'll query the data on that table. At that time, if it's not able to convert that data to the corresponding data type which it is expecting based on your definition of the table, at that time it will create problems for you. But at the time of table creation, it will not do anything. It will just store the metadata. So what I'm doing right now on the screen is, rather than calling this symbol as string, I've created that as int. एंड प्रैक्टिकली वो स्ट्रिंग है, क्योंकि आर ई एल एस बी आई थे, अगर आपने ध्यान दिया तो डेटा स्टॉक के नेम्स। एंड आई एम पॉइंटिंग दैट stocks 1 2 3 table on the same file or same folder. And basically what I'm trying to explain over here is, another point is, I can create n number of tables on the same directory on the same file. I will just store the metadata. जब मैं उस टेबल का नाम दूंगा hive को, hive उस टेबल की लोकेशन पे जाएगा और डेटा को प्रोसेस करना चालू कर देगा. So I'm creating another table on the same directory, but I've given the symbol as of type int. So table created successfully. Now just do a select. Select star from stocks 1 2 3. So देखा वो convert नहीं कर पाया and became null. Because it cannot convert that string to int. Got it? Prabjit, you are there with me?
या एक बार दोबारा मूव करना हो जो एरर।
एरर तो आया नहीं, कुछ एरर तो कुछ है ही नहीं, एरर नहीं शो करेगा।
नहीं, जब कन्वर्ट नहीं कर पाया तो
नल आ
एटलीस्ट
गया ना,
कुछ भी
फर्स्ट कॉलम,
नोटिफिकेशन।
फर्स्ट कॉलम नल हो गया ना, ये बस नल हो गया। इट कैन नॉट रीड इट, तो इट हैज गिवन इट टू एज नल।
ओके, तो मतलब उसको वो इग्नोर कर देगा बट एज सच फाइल को प्रोसेस कर देगा, राइट?
यप, यस।
बाकी ओके ओके फाइन, ठीक है। तो एक तरह से वो डेफिनेशन बना के अपने सिस्टम में रख लेता है। जब हम क्वेरी करते हैं तो वो मैप रिड्यूस का जो फंक्शन आपने बनाया था, सॉर्ट ऑफ उसी टाइप का कोई फंक्शन डेटा पे रन करता है, राइट?
यस,
एंड इट
वो बैकएंड
ट्राई
पे
टू।
मैप्रेडूस का कोड लिख रहा है, उसको रन कर रहा है एंड गिविंग इट रेट।
ओके। और हमें हम किसी तरीके से क्या, लाइक इज देयर एनी वे टू सी दैट कोड आल्सो कि उसने क्या रन किया क्या?
जो टेम्परेरी डायरेक्टरी में जाता है, यू कैन लुक एट दैट थिंग, बट मतलब एज सच डायरेक्टली प्री कुक्ड मिल जाएगा वो तो नहीं मिलेगा। वो टेम्परेरी डायरेक्टरी में जाता है। तो अगर इसमें देखोगे ना, तो ये जॉब ब्राउजर की हिस्ट्री देखोगे ना, तो वहाँ पे दिखाएगा वो मैंने जो यूआरएल दिखाया था ना एप्लीकेशन मास्टर की, वहाँ पे देखोगे लॉग्स में, तो वो दिखाएगा टेम्परेरी डायरेक्टरी एंड ऑल दोस थिंग्स। यहाँ पे आपकी जार बन के जा रही है, ऑल दोस थिंग्स। सो यू कैन लुक इट ओवर देयर, बट ऐसा डायरेक्ट वे नहीं है कि यू लुक एट द कोड विच इज क्रिएटेड। वहाँ पे जॉब ब्राउजर की हिस्ट्री में देखो एप्लीकेशन मास्टर में, तो वहाँ पे सब दिखाता है डिटेल में कि कहाँ पे वो जार कॉपी हुई है एंड ऑल दोस थिंग्स। So तो यहाँ पे कहीं तो दिख जाएगा। ये देखो ये जार इसने ना टेम्परेरी डायरेक्टरीज में कहीं रखता है, ये जो टेम्परेरी डायरेक्टरी में जार बना के रखी है। तो जार को अनकम्पाइल करके एंड ऑल दोस थिंग्स यू कैन ट्राई इट आउट, दैट विल देयर यू कैन सी द कोड व्हिच इज क्रिएटेड बाय दिस हाइव गाय। सो जार की लोकेशन भी एग्जैक्ट भी दिखती है कहीं तो। कंट्रोल है, तो जार्स भी बहुत सारी हैं। Just look at these log in these logs in detail. You will be able to figure it out. वो दिख जाएगी वो। So Shekhar, now does that make sense to you? You wanted to look at the file.
No, I'm good. Actually, I was wondering to myself that one thing which I collected is, अगर data type का mismatch हो गया, तो it will just show you a null output, right? It will say that he didn't find anything, correct? जो प्रभजीत ने question पूछा था, correct?
Yes.
Okay. And one more thing I was wondering is, if you query this table, so basically there is a table, there will be a file created for this table on the location which is specified. That is one thing. Then there is another data file which is existing outside this table file.
No, there's no. File is जो इतनी फाइल है उस डायरेक्टरी के अंदर ही, उस डायरेक्टरी के अंदर इतनी फाइल है उसको पढ़ेगा, that will be considered as a data for that table.
This directory. So dp.db / ये टेबल का नाम से लोकेशन विच यू गिव, राइट?
ये लोकेशन है, ये एक फोल्डर है, dp.db भी फोल्डर ही है, ये भी एक फोल्डर है। dp.db के अंदर अनदर फोल्डर स्टॉक्स, उसके अंदर फाइल पड़ी हुई है csv फाइल जो मैंने दिखाई दी अभी खोल के।
अच्छा, ये जो फाइल है
फाइल नहीं है, ये फोल्डर, ये फोल्डर है, एसडीएफएस में फोल्डर है, ये फोल्डर है, उसके अंदर फाइल पड़ी हुई है जो सीएसवी है।
एक मिनट, don't go back, just stay back on that black screen.
ये स्टॉक्स वाला फोल्डर है, इसके अंदर फाइल पड़ी हुई है स्टॉक्स डेटा।
Okay, and that is a CSV file, right?
Yeah, that is a CSV file.
तो मुझे इसका मैपिंग समझ में आया कि टेबल का जो हाँ ये ओके, तो मुझे इसका मैपिंग समझ में नहीं आया कि अगर हाउ डज दिस टेबल फाइल विल नो दैट इसकी डेटा फाइल ये है?
टेबल फाइल विल नो इसकी डेटा फाइल ये,
जैसे
यार कोई आपका जो भी डेटा है आप उसको पॉइंट करते हो टेबल, उसका हम वी जस्ट क्रिएट अ मेटाडेटा and that metadata is set to that metadata, basically we create a table on our file system. That table is nothing but a metadata about the file system. तो मैं हाइव को इतना बता रहा हूँ कि मेरे डेटा किस फॉर्मेट में, हाइव उस फॉर्मेट में डेटा को प्रोसेस करता है। वो डेटा इज लाइंग एट सम लोकेशन एंड दैट लोकेशन इज द लोकेशन एट विच टेबल इज पॉइंटिंग टू।
So how does the metadata information know where the data is?
वो तो हमने दिया ना टेबल बनाते हुए, लोकेशन इक्वल्स टू दिस।
Location spelled as stocks, right? This stocks is a directory, correct?
Yes.
तो इस डायरेक्टरी में it doesn't exist. Stock 1 2 3, तो टेबल का नाम 1 2 3 है, करेक्ट?
टेबल का नाम स्टॉक्स 1 2 3 है,
और उसको तुमने बता दिया कि भाई ये इसकी लोकेशन है, मतलब ये जो लोकेशन है वो डेटा की लोकेशन है।
यस,
इस फोल्डर के अंदर डेटा होगा जो भी होगा।
यस, वो इस फॉर्मेट में होगा।
वो इस फॉर्मेट में होगा।
अगर इस फॉर्मेट में नहीं है तो हाइव कन्वर्ट नहीं कर पाएगा, उसको नल दे दिया।
Okay, and then what did you say? Select star from stop 1 to 3. Okay.
अब वो स्ट्रिंग था, उसको इंट में कन्वर्ट नहीं करवाया तो वो नल दे दिया उसने।
ठीक है, ठीक है, समझ गया मैं।
ओके, ये प्रभजीत लेफ्ट। आई थिंक प्रभजीत गॉट डिस्कनेक्टेड।
मैं भी बीच में डिस्कनेक्ट हो गया था जब when you were trying to show this null screen and I didn't know that I got disconnected and then I came back again.
ओके, I'll just wait for him for 2-3 more minutes.
अच्छा, ये पॉसिबल है क्या? अगर सपोज उस go back to that stocks DB database stocks directory one more time. In this one, if you do a ls on this, basically if there are other data files existing, ये जो stocks data है, this is a flat file, correct?
Yes.
अगर इसकी जगह पे मैंने एक और डेटा रख दिया, क्योंकि मैंने तो उसको बताया कि डायरेक्टरी है, अगर मैंने यहाँ पे एक और फाइल रख दिया जैसे एम्प्लॉय डेटा और वो भी सेम फाइल में है, तो उसको भी रीड कर लेगा क्या?
सब कुछ रीड करेगा यार, वो तो जितनी फाइल पड़ी है डायरेक्टरी में सब रीड करेगा। कॉमा जैसे ही पहला कॉमा मिलेगा वो फर्स्ट कॉलम होगा, पहले कॉमा के बाद की सेकंड चीज दूसरा कॉलम हो गया, दूसरे उसके बाद जो कॉलम मिला उसके बाद की चीज थर्ड कॉलम हो गया, एंड सो ऑन। सो अगर उसमें करस्पॉन्डिंग डेटा
और जो
कर पाया तो ठीक है, नहीं तो नल दे देगा। आपने जेसन रख दी तो पूरी फाइल को सिंगल, पूरी लाइन को सिंगल फर्स्ट कॉलम में डालेगा।
ओके,
वो तो कुछ नहीं कर रहा, डेटा प्रोसेसिंग टूल है। आपने बता दी कि डेटा किस फॉर्मेट में, उस फॉर्मेट में पढ़ रहा है और आपको प्रोसेस करके दे रहा है, बस नथिंग एल्स।
आई हियर यू। नहीं, समझ में आ गया मुझे भी।
So similar kind of data you will put in a similar directory only. एक फाइल का डेटा आएगा, you will put into that directory into a SDFS and then will process with the help of Hive. You create a table, expose a table on that directory, and will process that table or data basically with the help of Hive.
तो इसमें एडवांटेज ये है कि कल सपोज करो कि तुम्हारा हर दिन नया फाइल आता है, तो या तो तुम फाइल को अपेंड कर सकते हो।
नहीं, फाइल को अपेंड करना, you will just put that file into the directory and that when next day you will do a select star, that data will automatically present in your select star query if you have placed that file next day into that folder. So each day आप data का dump ले रहे हैं यहाँ पे, you will just put that as a new file into your directory and that will be automatically considered in your table.
नहीं, मैं इसको अपने प्रोजेक्ट के रियल सिनेरियो से कोरिलेट कर रहा हूँ। सो let me give you that use case which I'm trying to think and see what would be the right solution. तो मेरे पास एक
yeah, we were waiting for you only. No, we were waiting for you.
Oh, okay, thanks.
तरुण कोहली,
ये मेरा एक्चुअली मेरे सीईओ का नाम है। मेरे अभी ऑफिस के सिस्टम से कनेक्ट किया है तो उसमें ये बाय डिफॉल्ट सेटअप है, तो मैं अपने से कर रहा हूँ दोबारा से।
ओके, नहीं कोई नहीं, मैं भी एक फ्रेंड है, इसलिए मैं सोचा कि वो कैसे आ गया यहाँ पे।
ओके, कहीं वही तो नहीं है?
He is here in US. So.
ओके, चलो मेरा हो गया लॉगिन आई गेस नहीं नहीं हो गया फाइन
हाँ, मैं ना एक प्रैक्टिकल सिनेरियो बोल रहा हूँ प्रभजीत, इफ यू रेडी देन आई कैन स्टार्ट सो दैट वी अंडरस्टैंड दिस पर्टिकुलर piece of it.
yes go ahead
Okay, so the practical scenario is this, that what I have is every transaction. So basically we deal with credit card. So what will happen is, so suppose if a employee, if the customer changes his account status, say from a card is cancelled to a new card is enrolled, so either we get uh, card update data or card insert data. Okay, so from relational database table, what you will get is all records which are updated to say Hadoop file system. So every day, first time when we do the first time upload, you will get the complete snapshot of the data, and it will come and say, in our example, it goes in the stocks folder. Now next day, the data which comes is not the complete data, but only the data which will be updated. So the question I have is, will you have a new file every day for the updated data, and how will it be synced with the previous data if the data has been updated?
So basically, as I told you, SGF is a file system which is created for writing new things. You can't update up the things. You can't update the file. All told you in the first day. So in such a scenarios,
Yes,
what
that's
is
true.
normally done in the industry is you get the database. So this is a very common scenario. So basically what is done is you create data pipelines with the help of Hive and Pig and MapReduce. That's the reason first day I told you create data pipelines. Your some of the data is processed with the Hive, then Pig query, or your n number of Hive jobs are running up, and all those things you do with the help of Uzi. So in such a scenario, what you'll do is your data dump will come in a folder. You will append that data dump with the existing table on top of your cars database. You will figure out the updates. You will merge the both rows into a single row and will create a new directory with the latest dump and will discard the previous data dump. So you create the data, you create the data flows which runs up and as a batch process at the end of the day when your dumps come up, and next day your latest table is pointing to the latest data or basically updated data. So you do all those things or processing with the help of Hive or Pig so that your updates are merged with your historical data.
Hmm. So every day you have to process so many records, right? In that case, when you are trying to merge the records. So suppose I'm talking about big data set, like say millions of records, and I get the updates in say 1,000 every day. Every day, thousands, 100,000 types of updates. So my first file will have millions of records, say 5 million, just to give an example. जनरली 50 मिलियन टाइप से होता है, तो सपोज 50 मिलियन रिकॉर्ड्स है. अब उसमें से हमारा 100,000 रोज अपडेट होता है. तो मेरी जो पहली फाइल होगी वो 50 मिलियन रिकॉर्ड्स होगा उसमें, और वो तो सब बढ़िया प्रोसेस हो गया, जैसे कि आपने बताया भाई कि ये टेबल का तुम स्कीमा डाल दो उसमें, और मैं आपको हाइप चला के देख लो कि क्या क्या डेटा है, कैसे स्टोर करना है. Now, the next day when it will happen that 100,000 more records comes in, so it will come as a separate file. So you see that I have card member and the date timestamp. We आ जा गया ये file. अब now what you're saying is in Hive you have to somehow merge these two files, जिसमें कौन से insert है कौन से update है वो तुम्हें पता लगाना पड़ेगा.
You have to just figure out based on timestamp. You will figure out the latest one. You will use those things, discard the previous ones, or basically, and then insert override the same directory with the latest update from the query.
Okay. ये कितना टाइम लगता है जनरली? बेसिकली इज इट so basically, if you are rewriting, say, 50 million records every day because of the 100,000 update you are getting, is this an efficient way to do it?
Yeah, reads and writes are extremely fast in SDFS as compared to your
Okay.
processing. So reads and writes does not take much sense. Only the thing which takes time is the processing.
बट
So
हाई लेवल यही तरीका है, इसके अलावा कोई तरीका नहीं.
in SDFS, no,
Okay.
because
So basically,
because updates are not possible in this file system.
right, I hear you. Okay. तो बेसिकली हर दिन तुम एक नया फाइल बनाओ और जो तुम्हारा अपडेट फाइल है और जो प्रीवियस डे का फाइल है, यू कैन डिस्कार्ड इट एंड दिस साइकिल विल गो ऑन.
Yes, yes. Yeah, फिर you can put your updated file into a new directory each day. Those are called partitions, and when you really want to read the data, you can figure out the latest from all the dumps which you have, historical dumps, and you can process the data on the fly when you want to read it. So based on your requirement, you can basically do a delayed processing, or you can process the data so that it's available processed. चाहे तो लेजी लोडिंग कर सकते हो, बेसिकली लेजी प्रोसेसिंग कर सकते हो, या फिर on the fly when the data is coming you can process the data.
Okay, one more small question. So update and insert is fine, but what if the data is deleted from the original table?
Again same thing.
Then that will not.
वो भी वही करोगे
फिर वो पता ही नहीं चलेगा ना कि वो डिलीट हुआ है.
तो भाई डेटा हार्ड डिलीट तो होता नहीं ना, you will get a delete flag only. हार्ड डिलीट थोड़ा ना कोई करता है आज के जमाने में.
ठीक है. वो किसी टाइप का ऑपरेशन कोड आता होगा जो
हाँ,
भी
वो तो
डेटा रिप्लिकेशन
वो तो आपके टेबल्स में होता होगा. हार्ड डिलीट तो नहीं होता ना, वो डिलीट का कोई फ्लैग फ्लैग होता होगा जो भी करते हो, आई डोंट नो. मतलब व्हाट्सएवर इज योर वे टू डिलीट द डेटा, यू वॉन्ट बी डूइंग हार्ड डिलीट. Or hard delete करो तो then you have to merge, basically look at you have to get the full dump each day. You have to just figure out कि क्या missing है, that's the deleted thing.
ठीक है, समझ में आया.
Okay, so tables, चलो इसको डिटेल में देखते हैं कल. पार्टीशन सेक्शनल टेबल्स, इट्स ऑलरेडी 11 ना. अभी मेस में जाऊंगा तो टाइम लगेगा. Let's look at this thing in detail and then we'll do a practical in tomorrow's class for Hive. I want you both to do a class practical for the Hive, at least in the class only. So please be ready with your laptop. MapReduce पे I did not force you because I know you will not be writing a MapReduce code in your lifetime. Till the time you are not a hard-coded Hadoop developer kind of thing. So, but Hive queries you will be definitely writing up. So tomorrow I'll explain you that this thing, external table, internal table in detail. And then I want you to do a practical which I'll give you in the class only. So you can show me that output in the class, because you will be writing Hive queries a lot of time if you start working on the, even on the day one, if you start working on the Hadoop world. So please set up your cluster and all those things if you're still not, and be ready with that thing. ठीक है?
It's yep. And Miraj, I needed your help for 5-10 minutes for.
Sure. I'll give you the control. I'll make you the presenter. And Prabhjit, if you want to stay, you can stay. Otherwise, you can drop off. And I'll stop the recording also.